Okay, so we are back and talking now about the contingency coefficient. So we can use this formula, which you can see it's similar to, but a little bit different than phi, because we, instead of having x squared or our chi-square value over our sample size, we're now providing sort of a ratio kind of measure. So the contingency coefficient is a chi-square based measure that's used with tables that are square in shape and contain at least one nominal variable. So they have to be 2 by 2s, 3 by 3s, 4 by 4. So in other words, there have to be the same number of columns as there are rows. So the same number of categories or response options for the independent variable and for the dependent variable. And the formula is the square root of our chi-square divided by our sample size plus our chi-square value again. In using this to assess religious attendance, I'm plugging in those same numbers that I had in the previous example, where we had a chi-square value of 34.2. And then, so on the denominator, we have 200 plus 34.2, and we end up with a contingency coefficient of 0.38. Now, for the interpretation, there's no direct interpretation, but the closer we are to 1, the more related the variables are. And although I used it on a 2 by 2 here, we don't typically use the contingency coefficient unless we have a very large table with at least 5 by 5, meaning 5 categories for each column, both the column variable and the row variable. And if you think about what's going on within the formula, again, we're accounting for the importance of sample size in the calculation of chi-square, and we're ending up here with sort of a ratio value that takes into account the sample size. And there's a link here to some more information about the contingency coefficient and when it's used and an example of its use in the statistics how-to page. I'm going to go ahead and talk about Cramer's V here rather than starting another video, since that was a relatively short one to explain. Cramer's V is a chi-square based measure, and it's used when you have different numbers of levels in your row and your column variables. So when you have a rectangle where you have one of the variables has more category options than the other. So Cramer's V is what we would use in doing that. And I think I have interpretations of the Bible here, and let's see what we have in the next slide. Now we have religious attendance, so I'll need to correct that. But just take that to be religious attendance, please. So we have the chi-square value divided by the sample size multiplied by k minus 1. And you remember k was in our calculations when we were doing ANOVA, right? Then the sort of number of groups minus 1 are k minus 1. So k here is the number of rows in the table or the number of columns in the table, whichever one is smaller. So whichever one is smaller, whether it's the number of rows or the number of columns, you put that in with a k minus 1. And so that becomes the component of the formula that is adjusted for the calculation of Cramer's V. So here we have the example again of religious attendance, but instead of using sex, because we needed something that was asymmetrical where we had more of one, so we have 3 columns for race here and 2 rows for weekly attendance or not weekly attendance. So because we are dealing with a rectangle, right, we have more columns in our independent variable than we have rows in our dependent variable. We can run Cramer's V for our calculation. So I ran a quick chi-square using that chi-square calculator that I showed you the link to before. And I found that the chi-square for this is 14.14 with an alpha level of less than 0.01. So it is statistically significant. So what we would be able to say then in the interpretation is that there is an association, a statistically significant association between race and religious attendance. But let's calculate Cramer's V and see what Cramer's V also can tell us about maybe the strength and the direction of that relationship. So the interpretation, there is a very strong relationship between the variables race and weekly religious attendance. Anything above 0.25 is considered to be very strong for a Kramer's V value. And I have the link here for calculating it and interpreting it from the statistics how-to page. But you can see that we had 2 columns in our religious attendance variable, right? So or 2 rows, excuse me. So we had attends weekly and does not attend weekly. So that 2, that's where this value is coming from. It's attends weekly and does not attend weekly. So 2 minus 1. And so we run through our calculation and we end up with a value of 0.28. So that's the calculation of Kramer's V. Most of these chi-square calculations are pretty simple, pretty quick to run. And as we are moving into ones that are not based on chi-square, make sure that you are able to distinguish between these and you know when to use them, because the determining factor is the size of your table, the size of your crosstab. So the number of columns and the number of rows that you have, whether you're dealing with something that's symmetrical or is a square, whether you're dealing with something that has a lot of columns or not very many columns and rows, or whether you're dealing with something that is asymmetrical, where you have more than one, either more columns than rows or more rows than columns. Okay, so I'm going to stop here and we'll pick up on lambda in the next video.